podcast. Today we're at journal page 50, connecting intercepts and zeros. A zero of a function is x value that makes the value of the function 0. The zeros of a function are the x-intercepts of the graph of the function. A quadratic function may have 1, 2, or no zeros. 1 0 has one x-intercept, 2 zeros has two x-intercepts, and no zeros has no x-intercepts. All right, good. Let's take a look at the next page. All right, example number 1. Solve the given quadratic equation by selecting the graph of the related function and finding its zeros. So one way to solve the equation is to set the left side equal to 0. So we're going to add 19 to both sides. So you have 4x squared minus 100 equals 0. Okay, so 4x squared minus 100. Okay, so in Desmos, we're going to graph f of x equals 4x squared minus 100, and we're going to graph g of x equal to 0. Okay. All right, so let's do that now. So we're going to graph 4x squared minus 100, and I said g of x, but in Desmos, we actually use y equals. So y equals 0. Okay. We're going to graph our points of intersection. Those are our solutions. Okay. So this one's okay so far. This is not. This is not. This is okay. So now we need to figure out if the graph has a y-intercept at 0, 100 or 0, negative 100. Okay. So to do that, we're going to go back to Desmos. We're going to zoom out. And we see it's 0, negative 100. So the answer is D. Okay, so f of x, which is this graph, and g of x is this graph. Okay. All right, so the zeros of the related function are negative 5 and 5. So x equals negative 5 and x equals 5. All right, let's take a look at the next example. All right, solve the given quadratic function by selecting the graph of the related function. All right, so again, we're going to set the left side equal to 0. So we're going to add 7 to both sides. So 2x squared minus 2 equals 0. So we have f of x equals 2x squared minus 2, and g of x equals 0. All right, so let's go ahead and graph that in Desmos. Now, first thing, you want to press the home key, and then you're going to exit out the previous problem. And then we're going to type in 2x squared minus 2, and you have to use y equals 0. All right, and we're going to click the points of intersection, negative 1 and 1. All right, so that's incorrect. That's okay. This is incorrect. This is okay. So now we need to figure out the y-intercept 0, negative 1 or 0, negative 2. So we go right here. It's 0, negative 2. So the answer is D. So f of x is this right here. And g of x is right here. All right. So the zeros of the related function are negative 1 and 1. So x equals negative 1 and x equals 1. All right, let's take a look at the next example. All right, solve the given quadratic by selecting the graph of the two functions and find their points of intersection. So we set, on the previous ones, we set the left side equal to 0. Now we're going to set the left side equal to the right side. So we're going to add 25 to both sides. So then you get x plus 8 squared equals 25. So f of x equals x plus 8 squared, and g of x equals 25. All right, so let's graph that in Desmos. So we're going to exit out the previous problem, and then parentheses x plus 8 squared, and then y equals 25. Now we're going to need to zoom out until we see both graphs. We do. We click on our points of intersection. So we see that x equals negative 13 and x equals negative 3. Okay. So we can see that this answer is not correct. See, that looks okay. This is not correct. And this is not correct. So the answer has to be B. So f of x equals is this right here. And g of x equals right here. All right, so the related functions are f of x equals x plus 8 squared. Let me rewrite that 8, make that look a little bit better. All right, and g of x equals 25. The graphs of the related functions intersect at negative 13, comma 25, and negative 3, comma 25. So x equals negative 13 and x equals negative 3. All right, go ahead and finish up that example. All right, so again, we're going to set the left side equal to the right side. So we're going to subtract 36 from both sides. So you get negative and put a 1 here. X minus 6 squared equals negative 36. We're going to divide both sides by negative 1. So f of x equals x minus 6 squared, and g of x equals positive 36. All right, so we're going to graph that in Desmos. And again, you always want to press the home key. And we're going to remove the previous problem, and then parentheses x minus 6 squared, and y equals 36. We're going to zoom out, and then we're going to click on the points of intersection. All right, so let's look. The answer is not B. A looks okay. C is not correct. D is not correct. So the answer has to be A. So we have f of x is right here, and g of x is right here. All right, the related function f of x equals x minus 6 squared, and g of x equals 36. The graphs of the related functions intersect at 0, 36 and 12, 36. So x equals 0 and x equals 12. All right, let's take a look at the next example. All right, so again, we're going to set the left side equal to the right side. So we're going to add 70 to both sides. So then you get -1 parentheses x plus 6 squared equals positive 70. We're going to divide both sides by -1. So you have x plus 6 squared equals -70. So f of x is x plus 6 squared, and g of x equals -70. All right, so let's graph that in Desmos. And again, we want to press the home key. All right, so parentheses x plus 6 squared and y equals -70. And we're going to zoom out. All right, we see that they do not intersect, and we see the graph shifted to the left. Okay, so this graph is shifted to the right, so it's not A. This is not correct. This looks okay so far, and this is not correct. So the answer has to be C. So we have f of x right here, and g of x right here. All right. So the related functions are f of x equals x plus 6 squared, and g of x equals -70. The graphs of the related functions do not intersect, so the equation negative parentheses x plus 6 squared minus 70 has no solutions. All right, let's take a look at the next example. Create a quadratic equation for the given problem, then solve the equation with the related function using a graphing calculator if necessary. Round your answer to the nearest hundreds. A monkey is in a tree 56 feet off the ground and drops a banana, which lands on the shrub 40 feet below. The function h of t equals -16t squared plus 56, where t represents the time in seconds, gives a height in feet of the banana above the ground as it falls when the banana lands on the shrub. So to find the shrub, we need to take 56 minus 40 equals 16. Okay, so we know the banana starts at 56, and we now know that there's a shrub at 16. Okay. All right. So we're going to graph. We're going to use Desmos, and we're going to go here, here, and press home. And then we're going to graph -16x squared plus 56. And we're going to graph y equals 16. Okay, we're going to need to zoom out a little bit. All right, so here, this point is where the banana started. And we're going to zoom a little bit. Yep. And then here is where the banana hit the shrub. Okay, so we have our point at 0, 56. And then here at the point 1.58 comma 16, but that banana hits the shrub. So banana falls. Here's your banana, right? It's falling. It hits the shrub at 1.58 and then hits the ground. Okay? So we can say that the banana will hit the shrub about 1.58 seconds. All right, let's take a look at the next example. All right, use the given quadratic function model to answer the question about the situation it models. If necessary, round your answer to the nearest tenth. A shark jumps out of the water. The quadratic function f of x equals -16x squared plus 17x models the shark's height in feet above the water after x seconds. How long is a shark out of the water? Okay, so we're going to go ahead and graph that function. Exit out here, and then you're going to press home. All right, and then we're going to graph negative 16x squared plus 17x. Okay, and the water is y equals 0. So that's all right. So the shark jumps out of the water here at 0. It gets to the height at 0.53, 4.51, and then it lands in the water at 1.1. Okay. Oh, I'm sorry, to the nearest tenth, so 1 decimal place. All right. So, zoom out here. All right. So the shark starts at 0, 0, goes to a height of, and I need to go back and look at the graph, 0.5, 4.5. So 0.5, 4.5 is right here. Okay. And then it hits the water at 1.1, comma 0. So the shark goes up. Here's our shark. Chomp, chomp, chomp. Jumps out of the water, goes up, and then comes back down and hits the water. And here, just so we're clear, here's the water. Okay, so the shark is out of the water for about 1.1 seconds. All right, let's take a look at the last example. All right, using the given quadratic function model to answer the question about the situation models, if necessary, round your answer to the nearest tenth. So that's 1 decimal place. A baseball coach uses a pitching machine to simulate pop flies during practice. The quadratic function f of x equals negative 16x squared plus 75x plus 8 models the height and speed of the baseball after x seconds. The baseball leaves the pitching machine and is not caught. How long is the baseball in the air? Okay, so let's go ahead and graph that. So I'm going to exit out, and then negative 16x squared plus 75x plus 8. All right, so we're going to zoom out. All right, so the ball starts at 8 feet, goes up to 2.3, 95.9, and back down at 4.8. Okay, so we start at 8 right here, so that 0.08, and then you go back to decimals because I forgot what the number was, 2.3 and 95.9. So 2.3, 95.9 is here, and then it comes back down at 4.8. Okay, so the baseball goes up and back down. All right, so we can say that the baseball is in the air for 4.8 seconds. All right, go ahead and finish up your examples, start working on your assignment, and have a wonderful